Well, good morning, class. This is Mr. Roberts at Shasta High School, and today we're going to be discussing the difference between relationships and special relationships. No, this isn't an advice show. This is a math show. But the difference between mathematical relationships and then sometimes we have special mathematical relationships, and when they're special, they have a name. We call them functions. So we've discussed the idea of functions before. They're things that take a value and give you a value. But one of the things that we like from functions is that they do so in a predictable and dependable way. So, for example, if I have a function and I'm giving it the number 3, right? I don't care what the output is, right? I just want it to always be the same thing. If I give a function 3, I expect it to give me the same consistent and predictable value back. And if I get something other than that same and consistent predictable value, I have a problem. So we're going to use this analogy to help illustrate this. But before we do that, I want to show you three relationships. And a relationship is nothing more than a connection between inputs and outputs. So you can see one, two, three different relationships. At least one of these is not a function. And by the end of the show, you should be able to help tell me which one is not a function. So the analogy we're going to use is that of a soda machine. They used to be on campuses all over the place, and when Arnold Schwarzenegger was the governor of California, he decided we were drinking too many sugary drinks and they disappeared. We were able to get them back in the form of ones that dispense Gatorade, right? But machines that will give you Pepsi or Coke, forget about it. This particular machine has fictitious beverages called Blast Slurp, Lemon Twister, and Diet Slurp. And let's go ahead and read. This is actually from our textbook, so you can follow along if the font is too small for you. It says the soda machine at your school offers several types of soda. There are two buttons for your favorite drink, Blast. It's fabulous. Two at the top too. It's the top two buttons, Blast. While the other drinks, Slurp, Lemon Twister, and Diet Slurp, each have just one button. The first thing that we're going to do is we're going to describe the inputs and the outputs of this soda machine. Now, I know what you're thinking. Input is like, well, okay, a modern machine, you might have like Apple Pay or Samsung Pay or something like that where you're tapping something. That's the input, and then it gives you the soda, or you put in quarters and it gives you something, right? The input is the money you put in. And certainly there is that element of you've got to place some cash in the machine before it dispenses. But the question is, what's the mechanism that lets you select the drink, right? And the inputs are pushing one of these buttons, right? You either push the blast button, the slurp button, one of the blast buttons, the slurp button, the lemon twister, or the diet slurp button. So for our purposes, the input is the button that we select after we've, paid the price to get in through the door. So that's our first thought. We have to tell it what. Next, while buying a soda, Miss Whitney pushed the button for lemon twister and got a can of lemon twister. Later, she went back to the same machine and again, pushing the lemon twister button. This time she got a can of blast. What? I just pushed the lemon twister button and now you're telling me I got blast? Is this machine functioning consistently? Now you could say, is it malfunctioning? I don't know that it's malfunctioning. It's probably just a fact that the person who loaded the machine put some of the they put some of the blast beverages in the slot that's supposed to be for lemon twister. So it was misloaded. But is the machine functioning consistently? No, it's not. It's not functioning consistently because if it were, I would expect that every single time I press this button, right, I would get the same beverage. And I have evidence that I've pushed it once and I got lemon twister and once and I got blast. So it is not functioning consistently. Let's move on. When Brandy pushed the top button for blast, she received a can of blast. Okay, so she's pushing for blast, she gets blast. When her friend Miguel decided to be different and pushed the second button, he too received a can of blast. Oh, okay. So if you push this button, you can get blast. And if you push this button, you can get blast. So both of these buttons go to blast. Each of them asked 5 friends to push the 2 blast buttons, and they all got the same result, a can of blast. Is the machine functioning correctly or consistently? Why or why not? Well, absolutely. That's not a problem, right? If I was to think about this in terms of a numerical function machine, I could say that this is the number 3, and I could say that this is the number 5. If I press 3 and I get, we're going to say that blast is the number 7. And then down here I press a 5 and I get the number 7. This is completely consistent. I apologize. I realize that you cannot see that well, and not though it's the most important thing that I would do today. Oh, go back there. Although it's not the most important thing I would do today, I definitely want to make sure that this is visible. So I'm going to pick a different color pen, and I'll just try this black. So I was calling this the number 3, and I'll call this the number 5. Right? When I push 3, it is apparently giving me, I'm going to say 7, and if I push 5, it gives me also 7. So what we're saying here is, yes, I can push the top button, I can enter a 3 in a numerical case, and I'm getting 7, I'm getting blast. I can also enter the second button, in this case press entering 5, and I also get 7. As long as every single time I press, I give the function 3 and it returns 7, it's functioning fine, even though 5 also gives me 7. So it's not a problem to have 2 numbers that are giving me the same output, right? That's completely legit. What the problem is, when we saw earlier when we were hitting lemon twister, if you remember the very first thing we talked about, lemon twister, and sometimes we would press this button, and sometimes we got lemon twister, and sometimes we got blast. That's a problem. So yes, this machine is functioning consistently. Both buttons are producing blast. In a numerical example, both 3 and 5 are producing 7. When Lutfi pushed the button for slurp, he received a can of lemon twister. Oh, we're pushing the slurp button. We're pushing this button, right? We're pushing the slurp button, but this person is receiving not slurp, they're receiving the LT, the lemon twister. Later, Taisha also pushed the slurp button and received a can of lemon twister. Still later, Taisha noticed that everyone else who pushed the slurp button received a lemon twister. Is the machine functioning consistently? And I would say absolutely, right? If you have this information and you watch it and you see it's not what should be loaded in that slot, but every single time I do this, I get that result, right? It is performing consistently, right? Even though maybe someone would be nice and come along and put a post-it note on it and say, hey, this is not really slurp. They could just put a little post-it note there and say on it, hey, this is the LT, this is the lemon twister, just so you know. Don't push the slurp button. Apparently we're out of slurp. But we do have diet slurp below. So let's come back to these function machines, right? If you look at these, as I go down them, you can see this first one every single time, and the very first one off to the left, every single time I enter 1, it's giving me 3. In fact, that's the only one I have, but this 1 is producing a value of 3. 2 is producing 6. There's nothing that contradicts that. 2 gives me 6, 2 gives me 6, 3 gives me 9, and 5 gives me 15. From this table alone, I would say that this relationship, if I'm limited to just those values, that relationship is a function. Same thing with the next one. If you notice, if I enter 1, it gives me 0. And down here, there's another 1, but it's also giving me 0. So it's fine that there are 2 1s that are listed in my input column, right, as long as they're giving me the same value. Same thing with 5, it's giving me 20. 5 is also giving me 20, and 2 is giving me 5. Those are not a problem. Over here for the last one, the fact that when I enter 2 and it gives me 3, right, that's great, because down here 2 gives me a 3. 2 gives me 3. 2 gives me 3. The problem that I have is when I enter 1, Sometimes when I give the function 1, it's reporting 1. Sometimes when I give the function 1, it's reporting 4. That behavior, right, is what causes me to say that this particular relationship is not a function, because I don't know what's going to happen with the value. Oh, I'm sorry, I apologize for that. I don't know what's going to happen with the value 2. I don't know that 2 is not behaving consistently and predictably. In fact, I could also do this. I could, just to further illustrate that what the problem is not. Let's say that I had a value 12 down here, and when I entered 12, it also gave me 3. So every single time I give it 12, it gives me 3, right? Nowhere else does it contradict that. That's fine too. It's totally okay that both the numbers inputs of 2 gives me 3, 2 gives me 3, 12 gives me 3. That's okay. Where we have the problem, where this ceases to be a function, is on the input when I give the function 1, right? When I give the function 1, it may give me a 1 or it may give me a 4. So this is not a function. It's a relationship. It's connecting x's to y's. It's a relationship, but it's not a function. Okay, let's look at a couple more examples, or a couple more things that I want you to do. So this one is question 44, and I would like for you to go ahead and pause and do this in your composition notebook. It says, in a relationship like the soda machine, we want the output to be consistent and predictable. When it is, we say that the machine is functioning properly. Examine each of the tables and graphs below that show different inputs and their outputs. Decide if the relationship could be described as a machine that is functioning properly. Explain your reasoning. So real quickly for part A, I just want you to pause the video and decide if 1, 2, and 3, if those relationships are functions or not functions. Okay, so for the first one, this one appears to start out well, right? If I press 1, I'm getting the sticks. 1, I'm getting sticks. If I press 2, I get M and N's. Uh-oh. Right here's my problem, right? You can see this button 2 is not behaving in a consistent and predictable manner. Sometimes button number 2 produces M and N's. Sometimes it produces the milk duds. So I would say that this is not a function. Let's look at the second one. So as I scan across the top here, there's a couple things that I think are slightly. 7 is always going to 6, and if I look, there's no other place where 7 is input, so I can't see that it falsifies that part. -2 is always going to -3. 0 is always going to 4. 4, I enter 4, I get 2, right? I enter 9, I get 10. I enter -3, I get -3. I enter 6, I get 0. The one place where you may say, hey, but I got 2 of the same things right here, right, is this. Okay, this is not a problem, right? Because every single time I enter 2, right, I'm getting -3. -2 gives me -3. -2 gives me -3. When I enter -3, I'm also getting -3, right? So this is completely fine. This is just like me having 2 different buttons, like right here above with the stick. It's fine that button 1 gives me stick, button 1 gives me stick. Down here, I've got 2 different inputs that are producing the same output. That's okay. The problem that I have is whenever an input gives me an unpredictable output, it doesn't give me the same output. So this one is a function. I should put some not a function. Is a function. And then let's look at the third one here. My eyes are immediately drawn to the fact that number 2 occurs twice. That in and of itself is not a problem, as we saw from this first example, right? Right here, the number 1 occurs twice also. But the fact that in the first instance, 2 gives me a 9, and in the second instance, 2 gives me a -8, indicates that this is not a function, right? It is not behaving consistently and predictably. Sometimes the input 2 gives me 9, sometimes the input 2 gives me -8. And because of that fact, we would say this is not a function. Now, the fact that 3 as an input gives me 4 and 1 as an input gives me 4, that's not a problem at all, right? Because 1 is consistently and predictably giving me 4. 3 is consistently and predictably giving me 4. The problem I have is that 2 is not behaving. 2 is doing different things sometimes. Here is our definition of a function. It says a relationship between inputs and output is called a function if the inputs and outputs behave like a soda machine that is functioning properly. Discuss with your team what it means. Well, you don't have a team, right? So one thing you can do is you can see this is a blue highlighted word in your textbook. If you hover over it and click it, if you're looking at the ebook, it'll give you the definition. But I think it's going to say something like this, right? A relationship is a function if each input value has no more than one output value. Let me say that again. If each input value has no more than one output value. So it is possible that an input could have no output, right? And we'll talk more about that tomorrow with domain and range. That's possible that an input could be not part of the output, or the input could be restricted from a function. So that's not a problem. But the problem we have is if an input has, so it could have no outputs, but the problem we have is when an input starts to have more than one output. If an x value has multiple different y's, that's when we're living in the land of the non-function. C. Examine each of the graphs and the tables below, compare the inputs and outputs, and decide if the relationship could be a function. Explain your reasoning. So one of the things, especially if you're looking at a graphical situation, an easy way to identify whether or not a relationship is a function is just using a vertical line. So if I was to bring this little line over here, you can see it right there. You'll notice that as I bring my line, you can see for this relationship on the first instance, when I'm entering -3, it's always going up to this one and only dot. It's the only value that is on that particular input. And if I bring my line over to the next one, you can see there's only the one there. This one only has one. This one only has one. This one only has one. And finally, this one only has one. So on each one of those stops, you can see all those different inputs. And as I move this line to the left and to the right, it's simulating different inputs. And you can see that those inputs didn't have multiple outputs. Now I want to contrast that. If I come way over here and I look at this swirling object, you'll notice right away that if I'm looking at this particular input, right, so I'm inputting this value, you can see that I've got different outputs, right? I have an output right here, I have an output right here, and I have an output right here. And maybe I should use a different color for those. So my inputs I'll make blue. I can't make blue. It became blue. Maybe it became blue. So my output looks like it's close to the number 1. And when I input that value into the function, you can see I'm getting 3 different possible y's. And because of that, we would say that this is a fine relationship. In fact, it's a cool looking, graph of this relationship, but this relationship is not a function because the number 1 is not consistently and predictably giving me just the same output. While we're here, let's look at the line below. If I look at this line below, this is a cool little curve, right? But you can see as it goes along, I'm never touching more than one point, right? And just to point out this fact that there's a couple things here that help me see why it's okay to have an inputs that have the same output. If I look at this, it looks very much like, if I would made a little t value, it looks very much like when I enter x is -3, it looks like it's giving me 0 for my output. And it also looks very much like when I give the function 0, it's giving me 0. And it also looks like when I'm giving it something very close to +3, it's also giving me 0. That's completely fine, right? There can be multiple inputs that give you the same output. So both -3 is giving me 0, that's this point, and 0 is giving me 0, and positive 3 is giving me 0. That's fine. The problem is when I have an input that's giving me multiple outputs. And in fact, let's look at the table of values. As I look at this, I can see that this appears to be a function, and there's a couple things that are informing this for me. First of all, I am drawn to the fact that there's a -8 twice in the table, right? That -8 appears in the very first entry and the last entry, but because they're both consistently and predictably saying 11, this is completely fine, and I'm still thinking that's still a function. 4 is always giving me 3, 11 is always giving me -8, and 6 is always giving me 3. So this is a function just fine. All right, we're at 20 minutes right now, so we need to stop for the day. You know what your homework is for this evening. I will leave you with just this one idea that I'd like for you to think about as you start the work for today, and it is this. Jade noticed that the line that graphed at right is a function. Hey, I think all lines are functions, she exclaimed. Is she correct? Support your claim with a diagram. Okay, so that's just something to think about, not a required problem. I hope you guys have a great day, and I'll see some of you back in class tomorrow, and I'll see some of you back in class on Friday.